Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. So I hope that you all are preparing for your upcoming examination. Hardly a month is left for your examination, and you all must be re-revising your syllabus again and again. And revision with writing is very important because when you see and revise and when you write and revise, there becomes a difference between both of them. And I would suggest you all that if your once or twice if your revision is completed, then pay focus on your mock test rather than just revision. So today is the class that is for all of you who are preparing for this year's examination, and we'll be discussing some of the important uh, questions that can be asked in your exam related to Poisson distribution. So let us begin. What is a Poisson distribution? We all know a Poisson distribution is a discrete distribution, right? And suppose X follows Poisson distribution with parameter lambda, then the PMF of X is equals to e raised to the power minus lambda, lambda raised to the power x upon x factorial, where x goes from 0, 1, 2 up till so on, and lambda is also greater than 0. This forms our Poisson. This forms our PMFR of Poisson distribution. This is the very basic concept and very basic distribution of our statistics, which is being used by us multiple number of times in every subject and in every topic. This Poisson distribution is used. Now, the questions that are based, we won't be discussing the question that are in detail, which can come on Poisson distribution, because that's not been asked in the examination. But the question that so that we can answer the paper one and paper two very quickly by saving our time, we can do that concept. So in paper one, generally distribution question has been asked, which comes under paper one. So paper one asks us about the distribution question. What are the distribution question? So if I say that x follows Poisson distribution with parameter lambda. This is our Poisson distribution. Now expectation of x, which is the mean of x, is lambda. We all know that. But how did this lambda came? Let us focus on that. Then we'll focus on what kind of questions can be asked. So this lambda is nothing but summation x goes from 0 to infinity x into fx, which is e raised to the power minus lambda, lambda raised to the power x upon x factorial. Now, if we sum it from 0 to infinity, the first one will be 0. So instead of writing 0, we can write it here. X goes from 1 to infinity, it will be same. 0 plus x summation x plus x goes from 1 to infinity, same as summation x goes from 0 to infinity. Okay. And now this is the denominator which forms x factorial. Now instead of x factorial, we can write it here as x minus 1 factorial. This x and the numerator x will get cancelled with each other, and we get it as summation x goes from 1 to infinity e raised to the power minus lambda, lambda raised to the power x upon x minus 1 factorial. Now in the denominator we have x minus 1 factorial instead of so that and in the numerator also we should have x minus 1 lambda raised to power x minus 1. So if I subtract and add plus 1 here, then it will be x lambda raised to the power x minus 1 into lambda raised to the power 1. So we can write it as, we can take the constant term outside, which is lambda e raised to the power minus lambda summation x goes from 1 to infinity lambda raised to the power x minus 1 upon x minus 1 factorial. Now this term, as we can see, This forms our summation of e raised to the power lambda. So this forms the product as, I am writing just this box, which is 1 plus lambda square lambda, 1 plus lambda minus lambda square, 1 minus lambda plus lambda square minus lambda cube, and so on up till 2 upon 2 factorial upon 3 factorial. This forms this, which is nothing but our e raised to the power lambda. Okay, so instead of this whole, we can write it as lambda e raised to the power minus lambda into e raised to the power lambda. These both get cancelled and we get lambda. So from here we can see, or we can determine that expectation of e of x is equals to lambda, right? Now if we do another thing, like if we take expectation of x, x minus 1, let us see the sum of this. The sum of this will be again x goes from 0 to infinity, x, x minus 1 e raised to the power minus lambda, lambda raised to the power x upon x factorial. Now from here we can see that the first term will be 0, second term will also be 0 when x is equals to 1, because 1 minus 1 will be 0. So we start the summation from x goes from 2 to infinity. Now from here we can see that x factorial is there, we can write it as x, x minus 1, x minus 2 factorial. So both of them get cancelled with each other. And in the numerator we know that lambda should have the power x minus 2. So we will multiply it by lambda square as well. So taking out the constant terms, lambda square e raised to the power minus lambda, summation x goes from 2 to infinity, e raised to the lambda raised to the power x minus 2 upon x minus 2. Okay, this is the one. Now this again is our representation of e raised to the power lambda, which will give us lambda square e raised to the power minus lambda into e raised to the power lambda, which will be cancelled and we get lambda square. So we can see that expectation of x, x minus 1, is nothing but equal to lambda square. Now, following this trend, if we see that expectation, if x follows Poisson distribution with lambda parameter, then expectation of x is nothing but equal to lambda. Expectation of x, x minus 1. Two numbers are there, then it is equals to lambda square. Means lambda square is an unbiased estimator of x, x minus 1. Lambda is an unbiased estimator of x. And expectation of x, x minus 1, x minus 2 will be equal to lambda cube by this theorem also. So if we follow this trend, we will get expectation of x, x minus 1, x minus 2, so on, x minus k. It will be equal to lambda raised to the power k plus 1, because this is the k term plus this one first term. This will be x lambda raised to the power k plus 1. And this forms the majority of questions in Poisson distribution. They can ask you directly. Let us suppose they ask you what is the expectation, what is the unbiased estimator of lambda raised to the power 5 from if x follows Poisson distribution with lambda. Then you can directly see that it is x, x minus 1, x minus 2, x minus 3, x minus 4. 5 numbers are there, 1, 2, 3, 4, 5. And the expectation of this will always be equal to lambda raised to the power 5. Directly we can give our answer if we know this property. Or one more thing, that if x follows Poisson 6. Then what is the value of expectation of x, x minus 1, x minus 2, if they have asked you this. Now what will you do? You will, in the exam, if you don't know this property, you will expand this as expectation of x square minus x into x minus 2, which will be equal to expectation of x cube minus x 2x, x cube minus 2x plus x square. Then you will simplify them differently, independently. Expectation of x cube, expectation of 2x, expectation of x square, and that will consume more time. But if you know this property, then this expectation, so this is not recommended to save time. This is a 1, 2 and 3. So it is the value of lambda cube, unbiased estimator of lambda cube. And lambda has been given as 6, 6 into 6 into 6, which will give us 216. Directly your answer. In the answers, they must be given 36, 216, or 225, or something like that. Then 216 will be your answer. Instead of calculating all of this, you can save your time by doing this. Okay. Now, this was your paper 1. What kind of questions can be asked from your paper 1? Now, if we move to paper 2, paper 2, majorly they asked in inference. So in inference, they ask us about UMVUE, sufficiency, completeness, unbiasedness and everything. So let us see for UMVUE. Now, if we have again x follows Poisson distribution with lambda as our parameter. Okay. Now they have given us, suppose we know that the for UMVUE, for finding UMVUE of lambda. Suppose we have to find UMVUE of lambda. For UMVUE of lambda, first of all, we should know what is UMVUE. UMVUE is uniformly minimum variance by unbiased estimator. And for this, we need to know this is the expectation of a function Tx or T theta lambda, let us say. And this function is sufficient plus complete for lambda. When expectation of a function of sufficient and complete estimator is taken, then that gives us UMVUE. Okay, I hope that you know the concept behind this. So for Poisson distribution, we all know that x bar, which is nothing but 1 upon n summation I goes from 1 to n xi, is the sufficient plus complete statistic. I'm not explaining the details of it here. We all know that it is the complete and sufficient statistic. You can use factorization theorem to prove the sufficiency and completeness. Okay. Now x bar is our sufficient plus complete statistic. Now we have to find the UMVUE of this. So we have to find something which is expectation of a function which is T lambda or Tx, suppose, which should give us unbiased estimator of lambda. Okay, this we have to find here. Now if we take, let us consider this only, expectation of x bar, which is, let us take this as t only. This has been given us to as t. Let us consider this. So expectation of 1 upon n summation I goes from 1 to n xi is equals to Now expectation will come on xi only, 1 upon n summation I goes from 1 to n expectation of xi. Now since xi follows Poisson lambda, then expectation will be lambda. So it will be 1 upon n summation I goes from 1 to n lambda. Now there is no I, so instead of summation we can write n lambda. N and n get cancelled and we get expectation equal to lambda, which we wanted to know what is the expectation of a function, complete and sufficient statistic that should be equal to lambda. So we can say that UMVUE of lambda is equals to x bar, or we can say 1 upon n summation I goes from 1 to n xi. This is the direct implementation. Now this formed the basic of our principle. Now we will be moving forward to how to attempt the question of this kind that can be asked in the exam. The simple one won't be asked in the exam. The difficult one, let us see. So this is one of your PYQs from 2016. It has been asked and it has been given that xi follow Poisson with parameter theta, and we have been given as t is equals to summation I goes from 1 to n xi. This is our statistic. Now we have to find UMVUE of theta square. Okay. Now for this purpose, first of all, we all know that expectation of t minus 1, or we can say first of all, see that if x follows Poisson theta, then t is equals to summation xi. T is equals to summation xi will follow Poisson n theta, right? From here we can see that expectation of t is nothing but n theta. Okay, now we will focus on t only. We know that expectation of, if we were doing the question like this, that if x follows Poisson lambda, then expectation of x follows is equals to lambda, and if x follows Poisson lambda, then expectation of x minus 1 will be equal to lambda square. Similarly, we will do for t here. If expectation of t minus 1, it will be always equals to theta square. We all know this. Okay. Now from here we can see that it is we are taking it will be n square theta square, because expectation of t is n theta, expectation of t minus 1 will be n square theta square. Now from here we can see that it will be t minus 1 upon n square is equals to theta. The unbiased, the uniformly unbiased, the uniformly minimum variance unbiased estimator for theta square will be t minus 1 upon n square. Direct implementation of the formula that we did just now, which is our option number A. Now, similarly, based on this, we can do one more question. Suppose x follows Poisson distribution with parameter theta only. Let us take theta, and we have to find the UV of theta q. Now simply we can say that t is equals to summation xi, then expectation of t minus 1, t minus 2 will be equal to what? Now from here expectation of t will be equal to n theta, and this will be equal to n cube theta cube from the property of our paper 1 theorem. Okay, and if we remove n cube from here and take it in the denominator, it will be this. This forms the uniformly minimum variance unbiased estimator of theta cube. So this one forms our UMVUE, and we can follow up till infinity term, and hence in general we can write it as expectation of t t minus 1, t minus 2 up till t minus k upon n raised to the power k plus 1 is the unbiased or UMVUE of theta raised to the power k plus 1, because these forms k and this is the one-eighth term, that is the general form. So I hope that you understood both the concepts, and many questions have been asked in your PYQs regarding these two concepts. So you can practice as many questions as you can from these two concepts, and if you have any doubt, you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. And keep on preparing for your examination. Keep on preparing for your examination. And one more important thing that I would like to tell you all, that Startup Academy has recently launched its new batch, which is Lakshya 2027. For all those who are preparing for ISS examination 2027, this is your opportunity to get the best coaching in all over India, where you will be directly focused on ISS preparation only. And for more queries, you can ask us anytime on our WhatsApp number. You can call or text us. Enroll now. Thank you. All the best.